Welcome to day 28 of your object oriented programming journey. Today is all about revising and practicing advanced OOP topics. You will be diving deep into real world coding challenges and enhancing your mini project by integrating advanced OOP principles. We will also take time to review and optimize your work, ensuring that you reflect on your learning process. Let's get started. Let's begin by revisiting some of the core advanced OOP principles. First, we have design patterns. These are reusable solutions to common design problems. Some examples include singleton, factory, observer, and strategy patterns. Understanding these patterns will help you solve complex software design issues effectively. Next, we have the solid principles. These are 5 key design principles that ensure your code is maintainable, scalable, and easy to understand. We will take a closer look at each principle: single responsibility, open or closed, Liskov substitution, interface segregation, and dependency inversion. These principles are the foundation for writing robust and flexible object-oriented code. Continuing with our revision, let's talk about inheritance. This allows you to create a class based on another class, inheriting its properties and behaviors. But be careful, overuse of inheritance can introduce unnecessary complexity. Next is polymorphism, a concept that allows objects to behave differently depending on their type. We will discuss both compile-time polymorphism through method overloading and runtime polymorphism through method overriding. Finally, we have abstract classes and interfaces. Abstract classes allow you to provide a common base for your subclasses, while interfaces enforce a contract that classes must follow. Understanding when to use each of these is essential for designing clean, reusable code. One of the key concepts in building resilient software is exception handling. In OOP, we use exceptions to manage errors in a structured way. Consider exceptions. Custom exceptions allow you to handle specific errors more gracefully. It's crucial to follow best practices when working with exceptions. This means using try-catch blocks appropriately and avoiding using exceptions for control flow. Here's an example you might create. Here's an example. You might create a custom exception for handling negative age inputs in a user profile system. Now it's time to practice. Let's apply the concepts we have just revised to real-world coding problems. For example, implementing design patterns like singleton and factory in your projects will help you manage resources and create objects more efficiently. Polymorphism and inheritance can be used to solve problems with method overriding and overloading, such as modeling real-world objects like vehicles or animals. You will also get the chance to refactor your code using solid principles, which will improve the maintainability and scalability of your system. As you continue enhancing your mini project, start by incorporating advanced OOP features. Design patterns like the factory and singleton are perfect for structuring and managing different components in your project. Additionally, refactor your code to follow solid principles breaking down large classes into smaller, more focused ones. Don't forget to implement exception handling to ensure your project can gracefully handle unexpected situations. Let's take it a step further. Add new features to your mini project such as user authentication, logging, and data validation. This will make your project more robust and production ready. If your project needs to handle large datasets, consider implementing caching for better performance. Optimizing your algorithms and reducing redundant code will also help ensure that your project scales well. Once you have added new functionality, it's time to review and optimize. A thorough code review is essential. Check for readability, maintainability, and efficiency. You will also want to focus on performance optimization, especially in areas with high time complexity. Consider adding caching or lazy loading where appropriate. Be sure to seek feedback from your peers or mentors as they as their input can help you make your project even better. Take a moment to reflect on your learning journey so far. Think about the challenges you have faced while grasping advanced OOP concepts such as design patterns or solid principles. How did you overcome those challenges? Celebrate your key achievements like successfully applying these concepts in your mini project. Finally, think about your next steps. What areas do you still need to improve, and how can you continue to grow as a developer? Looking ahead, day 29 will be all about testing your knowledge. You will be taking a comprehensive quiz covering everything you have learned so far. This will help you gauge your understanding of advanced OOP concepts. You will also have the opportunity to practice coding problems and mock interview questions. This will prepare you for the challenges ahead and help you feel confident in your OOP skills.